Hello everyone, my name is Zhongjun and I'm going to present the demo system of MithraCoverage, which discovers the population bias in a given dataset to address the intersectional fairness issue. Collaborators in this project also include Meng Jin, Chen Kai, Professor Jagadish from the University of Michigan, and Professor Abulfazl Al-Sudai from University of Illinois in Chicago. The full paper of MithraCoverage was published in ICDE last year. Without further ado, let's get started. It's commonplace today to train a machine learning model on a given dataset for various purposes. More often than not, such a learning is performed on so-called found data, meaning that the dataset has been acquired independently, possibly through a process on which the data scientist has limited or no control. A general expectation for such a dataset is that it must be representative of the distribution from which the actual test or production data will be drawn. However, we argue that model trained on a representative dataset can still be problematic, as a population bias problem may arise. The population bias problem indicates the models may perform differently across different groups. In a social science dataset, such a group may be based on genders, races, etc. A well-known example of the population bias problem is Google Gorilla. An early image recognition algorithm released by Google had not been trained on enough dark-skinned faces. When presented with an image of an African American, the algorithm labeled her as gorilla. Although Google very quickly patched the software as soon as the story broke, we think something should have been done beforehand to avoid such a mistake in the first place. We argue that it is not the algorithm or model, but the dataset itself is the cause of the issue. More specifically, the reason why models may have poor performance in some groups is that the dataset they were trained on is biased and do not have enough representatives from the minority groups. Here, we refer to this issue as lack of coverage. In this demo, we first demonstrate how MithraCoverage can help the data user identify coverage issue on a given dataset. But before the actual demonstration, we first go over a few key concepts. The pattern is a vector with deterministic or unspecified values in each of the dimension or attribute. Suppose a dataset has three attributes: gender, race, and age. Asian female subgroup can be a pattern here. A parent pattern is a more abstract pattern that covers a given pattern. For example, the subgroup of Asian is a parent pattern of Asian female. On the other hand, the child pattern is a more specific pattern that is covered by a given pattern. For example, Asian female aged 18 to 25 is a child pattern of Asian female. Uncovered pattern here is a pattern that the number of data tuples in the dataset matching this pattern is less than a threshold, tau. The maximum uncovered pattern is uncovered pattern that all of its parent patterns are covered. Suppose tau is 5, then the pattern of Asian female is a mob if this pattern covers only 4 instances, but both of its parents, Asian and female, covers more than 5 instances. So the ultimate problem for MithraCoverage is to find all mobs, aka more abstract underrepresented subgroups for a given dataset. Note that the child patterns of these mob patterns are also uncovered but will not be discovered and reported, because abstract patterns, aka patterns with fewer deterministic values, are more critical issues than specific uncovered patterns, aka patterns with more deterministic values. With these concepts in mind, let's now look at the demo. To identify the coverage issue using MithraCoverage for a given dataset, the user first needs to specify the file name of this dataset. To do so, the user can either upload a local CSV file or select from sample datasets in the system. In this demo, we upload a recidivism dataset we obtained from ProPublica. The current algorithm in MithraCoverage only tackles categorical data. We checkmark here to allow bucketization so that numerical data can also be processed. Next, we configure the coverage discovery process. The metadata including name, data type, cardinality, min-max value of all variables attributes of the dataset can be viewed here. In this dataset, there are 22 variables including gender, race, age, and some previous crime record statistics. Apparently, not all of these variables are critical to intersectional fairness. Hence, the user needs to select a subset of all variables that MithraCoverage should consider when evaluating coverage. For demo purpose, we choose 4 variables that are obviously related to intersectional fairness: gender, race, age, and marital status. Among these 4 variables, age is a numerical variable and we need to bucketize it. We set the number of bins to 7 and click here to bucketize it. We can see that MithraCoverage has turned it into a categorical variable. So the dataset has around 6,000 records. So we set the parameter tall to 2%, which is about 120. As mentioned before, we mostly care about the coverage problem in abstract patterns rather than specific patterns. So MithraCoverage has a second parameter, maximum covered level, which sets the limit to number of deterministic values a reported mob pattern can have. Here we set it to 3. We can now try to see what discover mobs under this configuration looks like. Although all variables the user selects are relevant to fairness, not all of these patterns are necessarily valid or critical. To eliminate them, we can specify invalid intersectional subgroups in step 2. For example, marriage status unknown is not an important subgroup, so we add it here. Suppose widowed young people are a meaningful subgroup, but hard to find in reality. We add this pattern too. And we regenerate the mob chart. We can see these invalid subgroups are removed. Our expectation for the end user is that once they identify interesting underrepresented subgroup in the dataset, they will move forward and remedy the problem. More specifically, they will add more data instances matching a mob pattern, and this pattern is no longer uncovered. The mob chart shows that Hispanic female is uncovered. Suppose we think this is not fair, and we upload a new dataset with additional 30 Hispanic female records. And we generate the mob again. MithraCoverage will show a new mob chart along with the diff chart to highlight the effects of the remedy. The first diff chart compares the number of discovered mobs and their levels. We can see that we now get fewer mobs at level 2, indicating the coverage issue is mitigated a bit with additional 30 instances. The mob diff information below shows that Hispanic female is no longer a mob. Although some of its child patterns are still uncovered, it is a less severe issue here. That's the end of our demo. Thank you for watching and feel free to reach out to us if you have any question.